Hi guys, I hope you guys are doing well and gradually adapt to this kind of situation. And I do appreciate you're really watching my videos. I got a report from YouTube that I got like 400 views in the past 2 weeks. That feels pretty good. Yeah, thank you. And but don't worry, I won't put any advertisement on my videos. Okay, anyways, we're talking about muscle mechanics today. It's like a transition from big scale mechanics, like we're talking about center of mass, angular momentum, and this lab we're talking about muscle specific or joint specific mechanics. And this lab previously is a discussion lab that we don't have hands-on data collection, we just discuss each scenario, and I want to restore that kind of vibe uh, still in this kind of situation. So I'll talk about this later. And for today, in this video, we're going to talk about exercise 1 that you can see on your manual. This is the table we're going to talk about in exercise 1. There are 8 scenarios, and we're just going to fill in all the blanks, and that's all for exercise 1. And we can take a closer look at the table. So there are motion, action, and muscles that we're going to fill in this scenario. And what does that mean? What does motion, action, or muscles mean? Here's an example. For motion section, we're basically going to fill in like extension, flexion, abduction, adduction, internal or external rotation. That's a motion of that joint specifically. And it can be one-dimensional, so probably only knee extension, for example. And there is no A, B, or adduction on knee joint or internal or external rotation. But it can be also multi-dimensional. And muscles is just a review of your anatomy section. And the action of the muscle, it can be isometric, eccentric, and concentric. Because it's a discussion lab, so in the video I'm going to talk about these 4 scenarios, and then I want you guys to discuss on canvas. I'll talk about the detail of discussion later. So for the first scenario, it's for knee joints specifically. They're in sit to stand, and the interval is from seat lift off until upright stance is achieved. So it's basically just from sitting to standing. It's pretty easy, right? For the motion for knee joint specifically is knee extension, because we're from sitting to standing is knee extension. You can imagine you can imagine a motion, right? And what muscle is involved in this kind of movement? For knee joint, is mostly the quadricep is doing the job, right? Quadricep is contracting to induce knee extension. And the action is concentric contraction, because the muscle is acting and the joint is following the acting direction. Okay, this is the first scenario. And for next scenario is for the spine, as a parent is lowering an infant to the bed of the crib. So it's spine specific. And the motion of the spine, thinking about when you're lowering something to the bed. Yeah, it takes a little bit imagination. And finally, you can see it's a spinal flexion, right? And the muscles, what muscle is doing? Do you think it's your abdomen, like your abs, or your erector spinae? So is it your trunk flexor or is your spinal extensor? Here's a tip. You can imagine if there is no muscle activation, what would the motion be? So if there is no muscle around your spine and you're trying to lower an infant to the bed, you're falling free falling, right?
Just a sec. Okay.
Yeah.
I found this on the web for smell mess around you.
Sorry, my Siri is talking. So you're basically your trunk will be free falling, like you're slamming the infant to the bed, right? So we need to slow down to like gently put the infant to the bed. So we are slowing down. We need a braking force, and that's from your spine extensors. So that'll be erector spinae and its eccentric contraction. And we're jumping to the third scenario. It's for a knee joint during landing from a jump, and from initial toe contact until your lowest center of mass. So from initial toe contact until your body center of mass is the lowest, it's knee flexion during landing, right? Your knee angle is from big to small. And a muscle, before we think about muscle, we can also use the same tip. Like imagine there is no muscle around your knee. What will happen when you're doing the landing? You're gonna fall quickly, right? You're gonna slam your butt onto the floor. So we need a braking force. And the braking force on the knee joint is coming from quadricep and its eccentric contraction, right? Okay. And the last scenario is for elbow at stationary position of 90 degree while holding a 20-pound box. So for elbow, is there a motion? No, right? Because it's stationary position at 90 degree. And what muscle is doing the work? Can still apply the same tip. If there is no muscle around your elbow will drop the box to the floor, right? So you need to hold it. You need your bicep to hold it. And it's isometric contraction. Okay, so we've talked about these 4 scenarios. Yeah, I hope you guys can imagine the motion pretty well in your mind. And so, I want you guys to discuss these 4 scenarios, and I've created a discussion session on Canvas. So you can see, like for this one, I put a scenario here. You're just basically going to type in the motion, the muscle, and action. And you need to post your answer before seeing others. I hope this can like promote your like encourage you to do this. This won't go into your grade, but if you really want to learn, if you really want to see what others think about and to make sure you're thinking it in the right way or to correct your flaws of thinking, I really encourage you to join the discussion session. And the discussion will be put in the module that you can easily find it. Okay, so that's everything for exercise 1. In order to make the video shorter, I'll do exercise 2 in next clip.